Imagine waking up, but instead of the usual soft morning light, two blinding rays hit your window from opposite sides. You walk to the window and see something incredible. Two suns shining in the sky. One, our very own, yellow and familiar. And right beside it, another one, smaller and reddish. Two shadows stretch from every tree, from every building, and from you yourself. One, sharp and dark, the other, more diffused and faint. Welcome to Earth with two suns. This isn't just a pretty picture from science fiction. This is a world where all the rules we're used to simply stop working. Let's get right to it. Could this actually happen? The answer is yes, and it's even more likely than you might think. In the universe, single stars, like our sun, are more the exception than the rule. Over half of all stars like ours live in pairs or even larger families. These systems are called binary or multiple star systems. They orbit each other in a gravitational dance, and planets can exist even there. Scientists have already discovered planets orbiting two stars. Perhaps the most famous of these is Kepler 16b, which astronomers playfully dubbed Tatooine, in honor of Luke Skywalker's home planet. So, a hypothetical Earth with two suns isn't a made-up story. It's an entirely plausible scenario. But there are two main ways this could look. In the first and simplest, Earth orbits one star, while the second star is very, very far away. In this case, the second star would appear as nothing more than an incredibly bright point in the sky. Perhaps brighter than a full moon, but nothing more than that. It would provide a little extra light and heat, but it wouldn't fundamentally change our lives. Boring, right? That's why we'll explore the second, much more exciting and chaotic scenario. Imagine two stars close to each other, with Earth orbiting both of them along a single, vast, shared orbit. This is called a circumbinary orbit, and it's in this very case that we would see those two suns in the sky, rising and setting, creating unimaginable landscapes. To make our thought experiment even more interesting, let's imagine the second star is a red dwarf. This is the most common type of star in the universe. They are smaller, colder, and dimmer than our sun. So, we have our yellow host star and its reddish companion. Well, buckle up. Our familiar life has just ended. The first thing that will change beyond all recognition is the very concept of day and night. Forget about the simple 24-hour cycle. Depending on the position of the stars in their own orbits and the Earth's position in its orbit, we're in for the most bizarre combinations. Sometimes both suns will rise and set almost simultaneously, creating an incredibly bright, scorching day and a relatively normal night. Other times, one sun will be rising as the other sets. This means that night as we understand it simply won't exist. An eternal day, one that smoothly transitions from a brilliant yellow light to a crimson twilight and back again. Imagine a world without darkness, where you could read a book outside at 3 o'clock in the morning by the light of a distant red sun. Such an erratic schedule of light and darkness would become a true nightmare for the biological clocks of all living things. Humans and animals have what are known as circadian rhythms, internal clocks attuned to the shift between day and night. They regulate sleep, metabolism, and hormone production. In a world of two suns, these rhythms would go haywire. Insomnia would become the norm, rather than a disorder. Perhaps living creatures would evolve to fall into short periods of sleep several times a day instead of one long night's rest. Nocturnal predators, relying on darkness, simply wouldn't survive. The entire ecosystem, built on the division of diurnal and nocturnal species, would collapse. But light is only half the problem. The other half is heat, and that's where the real climatic hell begins. The main condition for life to exist is the Goldilocks zone. This is a distance from a star where it's not too hot and not too cold for water to exist in liquid form on a planet. In our case, this zone will constantly shift. When Earth is closer to both suns, it will receive a double portion of energy. Temperatures will skyrocket to unbearable levels, turning the equatorial zones into a scorched desert. And when the stars diverge in their orbits, and Earth finds itself further away from them, a sharp cooling will set in, possibly even a new ice age. And that's not all. The stars will periodically eclipse each other from Earth's perspective. When the red dwarf passes in front of our sun, the overall light will dim slightly. But when our large sun eclipses the small red companion, the change will be almost imperceptible. These constant yet irregular fluctuations in incoming energy will turn the weather into unpredictable chaos. Hurricanes of unprecedented force, droughts giving way to floods, sharp temperature jumps of tens of degrees within a few days. All this will become commonplace. Seasons as we know them will cease to exist. Instead of spring, summer, autumn, and winter, there will be the season of two suns, the season of the distant sun, the season of eclipses. The calendar will have to be created from scratch, and it will be incredibly complex. The sky in such a world would be a truly fantastic sight. The color of the sky depends on how the atmosphere scatters the star's light. The light from our yellow sun gives us a blue sky. The light from a red dwarf star would most likely paint the sky in orange or yellowish hues. When both suns are overhead, the sky might have a strange, peachy tint. And the sunsets and sunrises. Just imagine, one sun dipping below the horizon, painting the clouds a fiery red, while the second is still high above, and the sky directly overhead remains a bright blue. Or two sunsets happening simultaneously, but on different parts of the horizon. Artists and poets would simply lose their minds over such beauty. But this beauty would come at an enormous cost. Gravity. The two massive objects at the system's heart would generate an incredibly complex gravitational field. Our moon, if it remained with us, would most likely be flung out of orbit or crash into Earth. But even without the moon, we'd face serious problems. Earth's tides are caused by the moon's gravity and, to a lesser degree, the sun's. In a world with two suns, the tides would be monstrous. Their height and power would depend on the stars' relative positions. At times, super tides, gigantic waves capable of washing away entire cities, would crash upon the coasts. Living near the ocean would be deadly. But that's not all. The complex gravitational pull of two stars would constantly tug at the planet itself. This could trigger immense geological activity. Earthquakes would become much more frequent and powerful. Volcanoes that have been dormant for millennia could awaken all at once. Tectonic plates would be set in motion. In fact, the planet's surface would be in a constant state of instability. Building skyscrapers or bridges under such conditions would be the height of madness. But what about life itself? Could it even emerge and thrive in such a hostile world? That's the most challenging question. On one hand, constant change and stress are the drivers of evolution. Life is incredibly resourceful. Plants would have had to adapt to light coming from different directions and having different spectra. Perhaps their leaves would have learned to turn not just toward one, but toward two light sources at once. Or, to escape excessive radiation during hot seasons, they might develop a shiny, reflective surface or retreat deep underground, leaving only their most resilient parts above ground. Photosynthesis could have evolved to efficiently utilize both yellow and red light. Animals would have an even tougher time. Difficulties with navigation, sleep, and finding shelter. That's just the tip of the iceberg. The constantly shifting temperatures would force them to either learn to enter a state of suspended animation during extreme periods or continually migrate to safer zones of the planet. Perhaps the most successful survival strategy would be to inhabit the subterranean or underwater world. Deep caves and oceanic trenches could become a cradle of life, shielded from the surface's radiation, temperature shifts, and gravitational storms. Imagine a civilization of sentient beings who have never seen the sun, but know of it from ancient legends, and for whom venturing to the surface is the most perilous journey one could ever undertake. And how would we ourselves change if humanity had evolved on such a planet? Our culture, mythology, religion, everything would be different. At the core of many Earth myths lies the dualism of light and darkness, day and night, good and evil. But what if there was almost no darkness? Perhaps myths would speak of the struggle between the yellow god and the red god, of their eternal dance, their alliance, and their enmity. Instead of fearing darkness, children would have a fear of double noon, the hottest and most dangerous time. Our perception of time would be completely different. The concept of a year, one revolution around the central stars, would remain, but it could last much longer than an Earth year. However, day and week would lose all meaning. Society would have to be organized around more complex cycles, tied to the position of both suns. Astronomy and mathematics would become the most important sciences from the very dawn of civilization, since the very survival of the species would depend on the ability to predict the movement of stars and, as a consequence, climatic catastrophes. Perhaps the eyes of such people would be structured differently. To protect themselves from the intense, constant light, they might have developed more powerful pupillary reflexes, or even something akin to a second translucent eyelid, like those of reptiles. Their skin, most likely, would be extremely dark to shield against a double dose of ultraviolet radiation, or, conversely, it would have learned to reflect the excess radiation. But let's be honest. The chances that complex life, let alone intelligent life, could emerge in such a world are incredibly low. Too much instability, too many deadly threats, constant bombardment by harsh radiation from two stars, especially if they are young and active, could simply sterilize the planet's surface. Gravitational chaos could cause the planet's orbit to become unstable over time, and it would either fall into one of the stars or be forever ejected into the cold interstellar space. And yet, the universe is full of surprises. The discovery of planets like Kepler-16b proves that worlds with two suns exist. And even if most of them are gas giants where life is impossible, who knows, maybe somewhere in a galaxy far, far away right now, on a rocky planet similar to Earth, a sentient being is watching a double sunset. Perhaps it also wonders, what if there was only one star in the sky? What if a world existed with predictable seasons, calm oceans, and a blessed, cool darkness descending every night? This thought experiment reveals just how fortunate we are. Our solar system is an island of incredible stability in the turbulent ocean of space. Our solitary, predictable sun, our steadfast companion the moon, our stable orbit, and our 24-hour cycle. None of this is a given. It's a cosmic jackpot. These are the ideal conditions that allowed life not just to survive, but to flourish, to evolve, and eventually to give rise to us. Beings capable of looking at the sky and asking questions. So next time you're watching a sunset and waiting for night to fall, remember the world of two suns. A world of eternal light, fiery tides, and unpredictable chaos. And perhaps you'll appreciate anew the simple beauty of our single sun and the tranquil darkness of night, which offers us respite and the chance to see other distant stars in the sky, each with its own untold story.